This video is for the discussion of structural isomers. Structural isomers, they are compounds that have the same molecular formula, for example, C4H10, but they've got different structural formulas. So for example, C4H10 could be a C, 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 straight chain like this, which would make it a bute. And if I put the H all in, that makes it a butane. So it's an alkane. But I can rearrange those carbons and make it a prop. And put one of the carbons in the middle here as a branch. It's still an alkane if I put in all the H. So let's complete that. So when I put in the 10H here, it's still an alkane, still saturated, but it's a prop. And at carbon number 2, there's a methyl. So it's 2-methylpropane. Although if you eliminate the 2 here and you said methylpropane, it still makes sense because there's no other place to put this methyl. There's no 3-methyl or 1-methyl. That would become a butane. I'll show you that. So if I have 1, 2, and 3, and if I put the carbon here and treat this as the methyl, this actually makes a butane. So there's no such thing as a 1-methylpropane. Therefore, there's only 2-methylpropane. We can eliminate the 2, but we usually will specify 2 here. Next, let's try a longer chain, C5H12, another alkane here. So 1, 2, 3, 4, 5. This is going to be a pentane. I'll put in all the H. And let's figure out if there's another way to draw this. Let's make a bute and put a branch somewhere. 1, 2, 3, 4, and the 5th carbon, we're going to put it as a branch. If I were to put it here, again, this is going to make a pent, because then this will be the longest chain. So this doesn't work. I'm going to erase this. How about if I put the methyl here? Okay, this works. So number 2 has the methyl. So methyl butane. Let's see if there's a number 3. So there you have it for 2-methyl butane. What about 3-methyl butane? Does that exist? Okay, so if I were to draw it like this, so number 1, counting from the left, 2, 3, 4. So number 2 has the methyl group. And now I'm moving it to the next carbon. So if I were to number the carbon from the left, it would be number 3. So in my mind, I'd be thinking 3-methyl butane, but that doesn't work because when we name it, we will put the substituent at a lower number. So I'm supposed to count from the right, 2, 3, 4. So if I have a 3-methyl butane, it's actually a 2-methyl butane. So there's no such thing as a 3-methyl butane. So that's just 1 for a bute, and let's move on to a prop. Now keep in mind that we can't put the methyl group at the first or the last carbon, because then that would make a longer chain. It's going to end up a bute if we were to put a carbon here, or if a carbon here, 1, 3, that's going to make a pentane. So this doesn't work. It'll have to go to the middle carbon. So That's the only place we can put the branch here. So 1. There's one more carbon because it's C5H12. So I can't put it on the first or the last carbon. Otherwise, it's going to make a bute or a pent. So no. So I'm going to put both on the middle carbon. So the branch goes here. So both are on number 2. So that's 2 and 2. Dimethyl. Let's put in the hydrogens. So it doesn't matter if you see your longest chain as this way. So it's still going to be 1, 2, 3. So still 2 and 2 is having this methyl group. Or alternatively, you can view it as 1, 2, 3. This is the longest chain. So 1, 2, 3. It's still the same name. So 2,2-dimethyl propane. When you're trying to draw all the isomers for C5H12, for example, you're drawing the buttes, try and put your carbons at the same position and only change where the substituent goes. For example, if you were to change the carbon position to something like this, you would have tricked yourself and think that this is another isomer, but it's not. Let's see why. This is the longest chain, and it's still 4. So 1, 2, 3, 4. And still the second carbon has the methyl, so it's still 2-methyl-butane. These are the same thing. So don't accidentally draw the same one just because you change the position of the carbons. So try to draw the carbons at the same position and move around the substituent instead. Let's try C6H14. So this is a longer chain. 1, 2, 3, 4, 5, 6. I'm going to fill in the hydrogens in a while. Let's see how I can alter this chain to something that is a chain of a pent. 5. 1, 2, 3, 4, 5. I can put it here. That's number 1. Number 2 has the methyl. 1, 2, 3, 4, 5. Here. So number 3 has the methyl. Can I do another one? 1, 2, 3, 4, 5, and put the carbon here. I shouldn't start counting from the right this time because that wouldn't make the smallest number for the substituent. So I should count from the left instead. So that's 1, 2, 3, 4, 5. It's still number 2, same as this one. So this is not another isomer. So there's 2 of a pent. So that's hexane. This one here would be 2-methyl pentane. This would be 3-methyl pentane. Let's try the next one. Let's try bute. 1, 2, 3, 4. I can put the methyl here or next to it. So 2, 3. I can put it as a 2, 2. Is there another way? Can I say 3, 3? No, I don't think so, because 3, 3 would be a 2, 2 if I start counting from the right side. So not this. What about 1? Remember what I told you about 1? The first and the last carbons. It's going to lengthen the chain, so that's going to make a pent again. So if I put number 2 here and number 1 here, you've accidentally tricked yourself because this would be a pent. 1, 2, 3. When you fill up all the hydrogens here, you'll find that it's the same structure as this one. So this is not valid as well. Let's fill in the other two structures. So this is number 2 and 3, dimethylbutane. This is 2 and 2, dimethylbutane. Can we make a prop? I don't think so. 1, 2, 3, 4, 5. To make it 6, if I put an ethyl here, it doesn't work because that's gonna make a bute. And number 2 has the methyl. You're gonna end up drawing the structure all over again. So no. Let's try one with a double bond. So this is C5H10 instead of 12. So 1, 2, 3, 4, 5. I'm gonna put the double bond here, or I can put the double bond here. And this would be number 1, and this is number 2. So pent 1 in and pent 2 in. Let's move on to a bute. So I'll put the double bond here first, the first one. And I'm going to move the methyl around. Okay, no other place to put my methyl. Let's name this. Smallest number for the functional group here, the double bond. So this is number 1. And if this is number 1, number 2 is having the methyl. This is still a bute 1 in, so I'm going to write that first. And 1 to 3 is having the methyl. There you go. Next, I'm going to change the position of the double bond. Remember, I told you not to change the position of the carbon, otherwise we might accidentally repeat the same structure again. 1, 2, 3, 4. Put the double bond here. Let's see if there's another place to put the methyl. 1, 2, 3, 4, double bond in the middle. What if I put the methyl here? No, that's not gonna work because 1, 2 is having the double bond and 2 is having the methyl group, as well as this one. 1, 2 is having the double bond and 2 is having the methyl group. They're identical. So no such thing. Let's complete this structure. Let's see if a prop is possible with this. 1, 2, 3, and a double bond. Can I put a carbon here and here? Because there's no other place to put the carbon. We can't put it at the terminal carbons. What's wrong with this picture? We know that carbons should have 4 bonds. This carbon in the middle already have 1, 2, 3, 4, 5 bonds. So this won't work. So there's no prop for C5H10. Alkenes are also isomers of cycloalkanes. Therefore, C5H10 is also a cycloalkane. 1, 2, 3, 4, 5, and 2 hydrogens here, 2 hydrogens here, and there we go, 10 hydrogens. This is a cyclopentane. Make sure that you don't accidentally write there pentane. alkenes because it doesn't have a double or a triple bond here. It's an alkane, but it's a cycloalkane. Some functional groups, they are isomers of each other. For example, alcohols and ethers. So propane 1 all looks like this. 1, 2, 3. Number 1 has the OH. We count all the carbons, there's 3 carbons. Count all the hydrogens, there are 8 of them, and there's 1 O, and methoxyethane has 3 carbons, 8 hydrogens, and 1 oxygen as well. Next, a carboxylic acid and an ester, they are isomers as well, functional group isomers. Butanoic acid, a COOH. Let's count how many hydrogens, oxygens, and carbons do we have here. That's C4, 1, 2, 3, 4, 5, 6, 7, and 8, H8, and O2. Let's draw propyl methanoate. This is propyl methanoate, and it's an ester. It's a functional group isomer with a carboxylic acid, which is this butanoic acid. Next functional group isomer, aldehydes and ketones. An example here, butanol and butanone. 1, 2, 3, 4. C double bond O. CHO here shows that it's an aldehyde. And a butanone would have the same number of carbons, 1, 2, 3, 4. The same number of oxygen. Let's move it here. And so it's C4, H8, O is just 1. So there's 4 carbons, 1 oxygen, and 8 hydrogens. There you go. This is a butanone, and it's a functional group isomer with a butanol. So both are C4, H8, and O. So these are some examples of functional group structural isomers.